Hello everyone, lesson 11.8, the final lesson in chapter 11, is on Heroes and Brahmagupta's formulas. That's a mouthful. Take a look at the quadrilateral that I have here, and as I play with this quadrilateral, see if you can see perhaps why it's special. This is a dynamic quad. Why is this special? There's something special about this quadrilateral and how it behaves. Maybe you noticed that it is inscribed in a circle. You can see how those sides are reacting as I pull them around. And that's what we call a cyclic quad. A cyclic quad is a quad that is inscribed in a circle. So this is a cyclic. Okay? So this belongs in our taxonomy. Where would this belong in our taxonomy? As I play with this, might think about some of the other shapes, like a parallelogram. Let's try to make a parallelogram out of this cyclic quad. We've looked at cyclic quads already to a certain extent. So let's see. Let's try to get a kind of play around with that a little bit. As you can see here, it's a little bit difficult to get a parallelogram. In fact, it appears that when I have the parallelogram, this appears to be maybe a rectangle. So we see that a rectangle is one of these. Could I drag this into a square? I could, I think. I think we could probably get this into a square with a little bit more work. So it appears that a square and a rectangle is. This parallelogram here, this general parallelogram, is not quite working out for us. Okay, I've made these two parallel, and these clearly are not. But boy, look at that. That looks a lot like an isosceles trapezoid. So we can see here that it appears to be that. A rhombus is going to be hard to create that. So feeling pretty good that my cyclic quad actually belongs right here someplace. Off here we have cyclic quad, and then it comes down to isosceles trap. So a square is always a rectangle, is always isosceles trap, which is always cyclic. Always cyclic. Every isosceles trap would be cyclic. So that's where it belongs in our taxonomy. Now our objective today is to find the area of a cyclic quad. There is a formula for finding this area. Okay. Now you think about what that formula is going to look like. So what I mean by that, just by looking at my taxonomy, we should be able to make some observations right off the go. Okay. For example, a square. The square is just each side squared is equal to the area, right? And then the rectangle is the base times the height. And the isosceles trapezoid is a trapezoid, so it's 1/2 the height base 1 plus base 2. Now notice what's happening as we move up the taxonomy. Okay, when we move up the taxonomy, we have less constraints. Notice how constrained a square is. A square is very constrained. It has to have all of the properties of a rectangle and more. And a rectangle, even more free than the rectangle is isosceles trap. The isosceles trap has got more motion than a rectangle does. And we can see here that my formulas for area are getting more complex. That's what I'm after here. I can use this square. In order to find the area of a square, I could use any of these three. And today we're going to learn a new one, cyclic. So even before I tell you what the formula is for a cyclic quad, you should already be bracing yourself for something that is more complex than this formula here, okay, because I'm further up on the taxonomy. So let's investigate, or let's go straight to what that formula is. Now, a man by the name of Brahmagupta is accredited for this formula. Okay, this formula, I'm just going to be forthright and tell you what the formula is. We need the side lengths of a cyclic quad. I'm going to call that length A, this length B, this length C, this length D. So I need to know the lengths of my sides, and I need to know that it's a cyclic quad. Alright, so the givens, so I'm going to need to be given the fact that it's cyclic. Alright, now they might tell me straight out that it's cyclic, or they might say that a circle, it is inscribed in a circle. So they could say inscribed in circle, right? That would be enough. I also need to know side lengths. So that's the necessary information in order for me to calculate the area. Alright, before we can find the area, we're going to calculate what we call the semi-perimeter, S. S is going to be the semi-perimeter. Well, you know what perimeter is. Perimeter is A plus B plus C plus D in this case. I just add them all up. Semi means half, right? So I'm going to cut that in half, and this is my semi-perimeter. You'll need to use the semi-perimeter from the information. You'll need to know the semi-perimeter before you can find the area. So here's the area formula. The area formula is this. So the area of a cyclic quad is equal to the square root of the semi-perimeter minus side length A multiplied by the semi-perimeter minus the length of B times the semi-perimeter minus the length of C times the semi-perimeter minus the length of D. Now you get what I'm talking about when I say a little bit more, I wouldn't say complex, but there's a lot more involved here because we're so high up on the taxonomy. So I need to find semi-perimeter, and once I have my semi-perimeter, this is just a plug-and-chug deal. Plug in your semi-perimeter in for S and find the differences between the semi-perimeter and each of the side lengths, the product of those differences. And then take the square root of that, and you've got your answer. Okay? So this is the formula that you will want to record and memorize for the cyclic quad. Alright, you'll also need to know how that semi-perimeter is found. Okay, semi-perimeter, just think about taking the perimeter and cutting it in half. Hence the name semi-perimeter. Let's try to put this into action here and take a look at an example. So find the area of a quadrilateral that is inscribed in a circle. Okay, there was that important given. I need to know it's inscribed in a circle. A common mistake that students are going to make is they're going to try to apply Brahmagupta on every quadrilateral that they run across, and that cannot be the case. You have to know that it is able to be inscribed in a circle. Okay, now whether you see the circle or not, you need to know that it can be. So here are the lengths: 2, length of side 7, a length of side 9, and a length of side 6. My area, since it is cyclic, is the square root of the semi-perimeter minus a side length 2 times my semi-perimeter minus a side length of 7 times the semi-perimeter minus the side length of 9 times the semi-perimeter minus the side length of 6. Okay? Now let's find our semi-perimeter. What's our semi-perimeter? Well, let's just find our perimeter. 2 plus 7 plus 9 plus 6. And divide all of that by 2. Okay, so add those up and divide by 2. What do we get? We get 12, right? Semi-perimeter is 12. So now I'm just going to take 12 and plug it in for all of my s's. Plug it in for all my s's and calculate. So the area equals the square root of 12 minus 2 multiplied with 12 minus 7 and 12 minus 9 times 12 minus 6. That is the square root of 10 multiplied with 12 minus 7, or 5, multiplied with 12 minus 9, or 3, multiplied with 12 minus 6, or 6. Multiply that up. 10 times 5 times 3 times 6. So we're going to multiply this to get, come up here, square root of 900. And now we always want to simplify. That's the square root of 9 times 100. Both of those are perfect squares, so that's 3 times 10. 30 units squared. 30 units squared is the area of the quadrilateral that's given there. Okay? Again, here's your formula. You just need to find the semi-perimeter, which is the perimeter divided by 2. And then you take the difference between the semi-perimeter and each of the sides and multiply all of those differences up. Take the square root of everything. Can you handle that? Again, it's a little bit involved, but it's very straightforward. Very simple to use once you have all your parts. Alright, let's look at number 4. Okay, Hero's formula for triangles. Now here's the point that I want to make here with this, is notice that every triangle is cyclic. Think about my quad, which we just got done with my cyclic quad. And what happens here? With a triangle, basically it's a quadrilateral with one side that is equal to what? One side is equal to 0. It is a quad with one side 0. So here's the area. So here is another area, another formula for the area of a triangle. We're going to use the cyclic quad concept. It is going to be the square root of, we'll call this A, this distance B, and this distance C. And distance D is 0. I'm going to take the semi-perimeter again, minus 0. Because that's the side length. My fourth side length is 0. Times S minus A times semi-perimeter minus B times semi-perimeter minus C. And there I have it. Now this can be simplified slightly because I know that S minus 0 is always S. So I'm going to rewrite it like this. Just the semi-perimeter times the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C. And that is Hero's formula. That's finding the area of a triangle. So we have a couple of ways to find the area of a triangle. 1/2 base times height, and now our new one, Hero's formula. Let's give it a shot. Find the area of a triangle with sides 3, 6, and 7. Now the nice thing about it, it works for any triangle. Any triangle. Every triangle is cyclic, right? So this works. Every triangle is cyclic. So let's draw my picture. I've got a side of 3, a side of 3, a side of 6, and a side of 7. Okay, so that's 7, that's 6, and that is 3. Find the area of it. What's very nice about this, I don't know what the height is. It's not a right triangle. So there's a lot I don't know. 1/2 base times height is not going to serve me well in this case. But I can use Hero's theorem, Hero's formula. Okay, so let's apply that. This time we'll find our semi-perimeter first. My semi-perimeter is equal to the perimeter, 3 plus 7 plus 6, all divided by 2. That's 16 over 2, which is 8. Okay, so my semi-perimeter is 8. I found it. Now let's use semi-perimeter in my Hero's formula. So area equals the square root of semi-perimeter times semi-perimeter minus 3 times semi-perimeter minus 7 times semi-perimeter minus 6. Those are the side lengths of my triangle. And my semi-perimeter is 8. So I'm going to take 8 times 8 minus 3 times 8 minus 7 times 8 minus 6 and evaluate. That's the square root of 8 times 5 times 1 times 2, which is the square root of 8 times 5 is 40 times 2 is 80. Simplify square root of 80. That is what perfect square goes into 80, or 4 does, right? So 80 divided by 4 is 20. So I could think of it like this. 8 and 10, 5 and 2, 4 and 2. So I've got 4 is a perfect square, and I have another 4 as a perfect square. So this is equal to 4 root 5 units squared. Okay. All right. There's one concept here that I would hope that you would understand, and that is you should understand that if I have a triangle and I know all 3 sides, then there should be a formula that finds the area of it. Let's think about why. Well, going back to our congruence, side, side, side gives me congruence, right? So what that means is, if I know the 3 sides of a triangle, it's fixed. There's no more motion, there's no more movement. If I know all 3 sides, it's rigid. And if it's rigid, that means area is fixed. And if area is fixed, that means we should be able to find it using side, side, side information. Okay? So I would hope that you would have that sort of understanding about it. So really only one formula for today, and that's Brahmagupta's, and then you can apply it also with the triangle when that 4th side is 0. Okay? So that concludes us for tonight, and we'll see you in the morning.